Hello students, we are going to discuss about uh, factor affecting adsorptions of gas molecule and solid adsorbent. Factors affecting adsorptions of gas molecule and solid adsorbent. So in this case, before going to discuss about, we should know the following keywords like what is meant by adsorption, adsorbent, adsorbate, sorption, like that. Before that, what is meant by surface tension? Surface tension, then adsorption, then adsorbent, adsorbate and adsorbent, adsorbate, sorry, this is the adsorbate, this adsorbent, then sorption. So first one, surface tension. We know that unbalanced or residual force act along the surface of the liquid. That is called, it gives rise to surface tension. So we know that such a force also exists on the surface of the solid as well as liquid. So the unbalanced or residual force act along the surface of the body of liquid as well as solid, that is called a surface tension. So what is in the adsorption? Adsorption is the generally surface phenomenon. So this adsorption phenomenon of higher concentrations of any molecular species at the surface than in the bulk of the solid, that is called adsorption. So adsorption is the surface phenomenon. It is the surface phenomenon. What about the adsorbate, adsorbent, sorption, like that? Then one more thing, absorption, AB. Before that, it will be absorption, AB. Finally, sorption. These are all basic keywords. So adsorption, it is a surface phenomenon. So it is the any molecular species at the surface there in the bulk of the solid, that is called the adsorption. Here, the fine particles are having highest number of surface area. That is the best example for adsorption process, like it is the surface phenomenon. Next one, adsorbate. That is the gas or the substance or solid which hold to the surface of the solid, that is called adsorbate. Then adsorbent, the solid that takes away gas or vapor or the solid from solution, that is called adsorbate. What about the absorption? It is the bulk phenomenon. So it is just a reverse for adsorption. It is the reverse for adsorption. So it is the substance is distributed uniformly. Substance is distributed uniformly throughout the body of surface of the solid or liquid. That is called absorption. So absorption is the bulk phenomenon. Adsorption is the bulk phenomenon. This adsorption is the surface phenomenon. Adsorption is the surface phenomenon. So this is the bulk phenomenon. So what about the sorption? Both adsorption as well as absorption takes place simultaneously. That is called sorption. So this, all the keywords are explained by the M.C. Bain. He is the scientist, explained by the M.C. Bain. This, all the key points are illustrated by the following diagrams. Like that, the diagrams may be like this is the adsorbed molecules. So this is the adsorbent. So this is the adsorbed molecule, adsorbed molecules. This is the adsorbent. For example, silica gel or alumina gel, like that. So this is the adsorbed molecule. This is the simple example for adsorption process. Then one more example like absorption, AB. This is the bulk phenomenon. So if you consider same adsorbent, but we absorb the molecule should be entire molecules. That is the bulk phenomenon. So that is the absorption. So this is the absorption, this is the adsorption, AD, surface phenomenon. The molecules only are adsorbed on the surface of the molecules. It will not go to the deeper into the bulk. So the molecules only adsorbed and retain the surface of the molecule. It will not go to the deeper into the bulk. That is called adsorption. So it is just a reverse for the absorption, because the molecules absorbed uniformly throughout the body of the liquid or solid. That is called absorption. So now, what is the difference between adsorption and absorption? Absorption and adsorption. So for example, first one, few difference. First one, adsorption. Next one, absorption, AB. We know that adsorption, it is the surface phenomenon, this is the bulk phenomenon. It is the surface phenomenon. First point, it is the surface phenomenon, it is the bulk phenomenon. Then number two, equilibrium is attained very easily. It will take more time. It is very easy, it will take more time. Then it is the rapid process, it is slow process. It is rapid process, it is slow process. Then one more difference, the concentrations of the molecules highest on the surface of the molecules. Here, entire molecules, the concentration of molecules distributed throughout the body of the liquid or solid. So these are all maybe the general difference between adsorption and absorption. Then generally the adsorption, here after that we are going to discuss about only the adsorption, AD, adsorption. So here the molecules, gas molecule adsorbed on solid adsorbent, based on that the things, it will be divided two types. The classification of adsorption. So classification of adsorption, generally it's two types. One is physical adsorption, next one chemical adsorption. Physical adsorption, next one chemical adsorption. So the physical adsorption may be the another name, may be the physisorption. The chemical adsorption, another name, chemisorption or activated adsorption. This physical adsorption or physisorption or weak van der Waals adsorption. The second one, chemical adsorption or chemisorption or activated adsorption. So these are the two types. So first one, physical adsorption. The physical adsorption, the force of attraction between the molecules, due to it's very weak, that's why it will be called as physical adsorption. The force of attraction between the molecule is very weak, or interplay of these forces between the molecule is very weak. That's why it will be called as physical adsorption or physisorption or weak van der Waals forces. Weak van der Waals forces. Weak van der Waals forces. The force of attraction between the molecule is very weak. That is called a physisorption or physical adsorption or physisorption or weak van der Waals adsorption. Next one, chemical adsorption or chemisorption or activated adsorption. So this just a reverse for physical adsorption. The force of attraction between the molecule is very high due to the formation of strong chemical bond. So that's why it will be called as chemical adsorption or chemisorption or activated adsorption, due to the formation of strong chemical bond formation. So that is the best example. For the physical adsorption, due to the weak van der Waals forces between the two molecules, that's why it will be called as like a physisorption or physical adsorption. Best example, hydrogen molecules on charcoal. This chemical adsorption, due to the force of attraction between the molecules, like gas molecule and solid adsorbent, is very strong due to the formation of strong chemical bond. So the best example, like hydrogen on nickel surface. So that is the simple classification, physical adsorption and chemical adsorption. Now we are going to tell the simple difference between the physical adsorption and chemical adsorption. So first difference, physical adsorption, it will be due to the weak van der Waals forces. This type of adsorption caused by weak van der Waals forces between the molecules. But in chemical adsorption, just reverse, it will be a strong chemical bond formation or covalent bond like that. So due to the force of attraction between the strong chemical bond formation. First point. Next one, equilibrium is attained very easily. Which one? Physical adsorption. But equilibrium is not easily obtained because it will take more time because surface compound is formed. Then that is the second one, because for example, like a hydrogen on nickel surface, it will be involved in physisorption and followed by chemisorption. So that's why it will be a strong chemical bond formation. So it is the equilibrium is not easily attained. Then third one, the heat of adsorption is very low for physisorption. Heat of adsorption is very low for physisorption. For example, 30 kilojoule per mole. 30 kilojoule per mole. But in chemical adsorption, the heat of adsorption is very high, near about 40 to 100 kilojoule per mole. 40 to 100 kilojoule per mole. Then when we increase the pressure, increase the temperature, the physisorption is inversely proportional. So when we increase the temperature, physisorption is decreases. Physical adsorption is decreases. But in chemisorption, it just reverse. When we increase the temperature, the rate of chemical adsorption is also increases. But this only for temperature. Next one, pressure and concentration. Pressure and concentration, we have to increase the pressure and concentration. What about the physical adsorption? Directly proportional to physical adsorption. But it will be inversely proportional to chemical adsorption. Pressure and concentration increases means definitely chemical adsorption may be decreases. So the best example, hydrogen on charcoal, that is the physical adsorption. Then chemical adsorption may be the hydrogen on nickel. So this hydrogen on charcoal may be the physical adsorption followed by physisorption or weak van der Waals forces, because there is no any surface compound. This equilibrium is attained very easily. For especially the physical adsorption, equilibrium is attained very easily, but chemical adsorption, already surface compound is formed, so that's why it cannot get reversed. So that is the chemical adsorption or chemisorption. So these are all simple difference between physical adsorption and chemical adsorption. Now we are going to discuss about what are the factors to affecting the adsorption, especially the gas molecules on solid adsorbent. So for the following factors, we will list out the following factors, few factors about the gas molecule and solid adsorbent. First one is maybe the nature of gases. First factor, nature of gas. Next factor, temperature of gas. Third one is activation of adsorbent. Fourth one is thickness of adsorbed layer of gas. Then fifth one, reversible nature of adsorbed layer of gas. Reversible nature of adsorbed layer of gas. Sixth one, enthalpy of activation. Last one, seventh one, nature and surface area of the adsorbent. Last one, pressure of gas. So first one, these are all maybe the following factors to affecting gas molecule and solid adsorbent. First one, nature of gas. We know that easily readily soluble and liquefiable gases such as like ammonia, sulfur dioxide, then carbon dioxide, hydrochloric acid. These gases are maybe adsorbed very more than that of the permanent gases. The permanent gases may be like H2, N2, Cl2, O2, like that. So ammonia, sulfur dioxide, carbon dioxide, hydrochloric acid, these gaseous molecules are, especially it will be adsorbed more on the solid adsorbent than that of these permanent gases. Why? Because these types of gaseous molecules having the force of attraction between the molecules are very weak. That's why between the force of attraction should be a weak van der Waals forces existing between them. That's why these gaseous molecules are adsorbed and solid adsorbent. It will be more than that of the permanent gases. Then one more example for that nature of gases may be if the molecules, gaseous molecules having highest critical temperature, definitely it will be more adsorbed more and liquefied more readily. So that is the example for nature of gas. For example, this we have to give those few examples for this one: SO2, then NH3, ammonia, then CO2, then hydrogen. For example, this may be the gaseous molecules. The critical temperature of sulfur dioxide may be sulfur dioxide, SO2. Sulfur dioxide is 430 critical temperature. Critical temperature of sulfur dioxide is 430. Amount of gas adsorbed. Amount of gas adsorbed is 180. Then ammonia is 406. The amount of gas adsorbed is 48 milligram per liter. Then carbon dioxide is 304. Thus amount of gas adsorbed is near about 8.0. Then last one, hydrogen gas. This may be the 33. Critical temperature is 33. It will be absorbed only 4.5. So this is the best example for the nature of gas, like this SO2, ammonia, carbon dioxide will be absorbed more than that of the permanent gases like hydrogen, nitrogen, chlorine, oxygen, like that. Because this types of gases are weak van der Waals forces exist between them. One more things, these types of gases are having highest critical temperature. Highest critical temperature. For example, sulfur dioxide is 430. Adsorption is amount of gas adsorbed on the solid adsorbent is 180. Same, ammonia is 406. The amount of gas adsorbed is 48 only. Then carbon dioxide 304, 8.0. Then hydrogen 33, 4.5. And compared to this sulfur dioxide, ammonia, carbon dioxide, hydrogen gas is very, very low adsorption. So that is the nature of gas. The next factor is temperature of gas. Next factor is temperature of gas. So second factor is temperature of gas. Temperature is also one of the main factors to determine the gas molecule and solid adsorbent. So the temperature, if you raise the temperature, just we are going to tell the factors affecting the gas molecule and solid adsorbent. Just we recall the difference between physisorption and chemisorption. Difference between physisorption and chemisorption. So if you increase the temperature, what about the adsorption, especially in physical adsorption? Physical adsorption. When we increase the temperature, the physical adsorption may be decreased because the molecules are very weak van der Waals forces in between the gas molecule and solid adsorbent. That's why the rate of adsorption should be decreased. So when we increase the temperature, rate of adsorption rate should be decreased. For example, the coconut charcoal increase the temperature from -30 to -80 degrees Celsius. -30 to -80 degrees Celsius. Coconut charcoal. Coconut charcoal is lowered from -30 to -80 degrees Celsius. But so the same thing, the amount of gas adsorbed on the solid adsorbent, like they increased from like same 20 to 40 milliliter under the same pressure. Under the same pressure, nitrogen gas adsorbed on the solid adsorbent increased from 20 to 40 milliliters under the same pressure. That is the example for physisorption. So if you raise the temperature, the rate of adsorption should be decreased. Then one more thing, this will be explained by the following diagrams. Like this is the temperature, this is the adsorption. So this is the adsorption, this is the temperature. When we increase the temperature, adsorption will be not increased, it will be decreased, like the parabola. Then one more thing, chemical adsorption. Second one is chemical adsorption. What about the chemical adsorption? Like temperature of gas. When we increase the temperature, definitely the chemical adsorption is directly proportional. Chemical adsorption is directly proportional. When we increase the temperature, increases the rate of adsorption. After reach the maximum, it will maybe decreased. For example, this may be the line. So this is the adsorption. This is the temperature. X-axis may be the temperature. Y-axis is the adsorption. When we increase the temperature, rate of adsorption, chemical adsorption, rate of adsorption is also increases. It will reach the maximum. After that, it will be decreases. So the increase of adsorption, especially increase of temperature, it will increase the magnitude of adsorption. So especially the physical adsorption may be decreased, chemical adsorption may be increased. So that is the second factors. Then third one, activation of adsorbent. Third one, activation of adsorbent. Activation of adsorbent is also plays the major role for increase the surface area of the adsorbent. So the activations is achieved by the following two methods. First methods may be creation of rough surface area. Creation of rough surface area. Creation of rough surface area. Number two, increasing the surface area of the adsorbent. 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 First one, the activation is achieved by the following two methods. First method may be the creation of rough surface area. The rough surface area may be created by two methods, the following two methods. First one is maybe rubbing mechanically. Rubbing mechanically, or second method, maybe we have to carry out subjecting to some chemical reaction on the solid adsorbent. Subjecting to some chemical reaction on solid adsorbent, it will also increase the creation of rough surface area. So this is the first method. Then second one, next one, increasing the surface area of the adsorbent. Increasing the surface area of the adsorbent. This method is also, we have to done the following two types. One is maybe the when we converting from bigger particle into finer particles. So number of particles are maybe increased, automatically it will directly proportional to the surface area. It will also leads to increases the adsorption. So big particle, fine particles, when we converted from big particles to fine particles, it will also leads to surface number of pores may be increased, automatically it will increase the surface area of the adsorbent. Surface area of the adsorbent. So next one, second method. When we increase the temperature, to the adsorbent, it will help to increase the temperature, especially in superheated steam. It will help to increase the number of pores. It will help to increase the number of pores present in the adsorbent. Superheated steam, we have to apply the temperature to the solid adsorbent. It will help to increase the number of pores present in the adsorbent. So automatically number of pores are may be raised. Number of pores may be raised. What will happen? Automatically increases the surface area. So surface area increases, it will be directly proportional to adsorption. So these are all maybe the example for increasing the surface area of the adsorbent. So this first method, like big particle into finer particle, number of fine particles are maybe increased, automatically pores are maybe increased, then surface area is also increased, then automatically it will leads to increases the adsorption. Then this second one, we have to raise the temperature near superheated steam. This operation will helps to number of pores present in the solid adsorbent. So the surface area may be increased, automatically it will leads to increases the adsorption. So that is the activation of adsorbent. Then third one, thickness of adsorbed layer of gas. Thickness of adsorbed layer of gas. Then according to the longer adsorption isotherm, the physis options may be shows the monolayer thickness. But at certain pressure, this physis option may be form multi-molecular layer. In physis option forms a multi-molecular layer thickness. But in chemisorption, it will be form only monolayer adsorption. This multi-molecular layer is formed due to the weak bond wall forces between the gas molecule and solid adsorbent. But why the chemical adsorption may be form only the monolayer due to the strong chemical bond formation between the gas molecule and solid adsorbent. That is the reason for thickness of adsorbed layer of gas. The next one, fifth factors like reversible nature of adsorbed layer of gas. This reversible nature of adsorbed layer of gas, like first one, the physical adsorption. The gas molecule adsorbed and solid adsorbent, it can be reversed. It can be reversed under the same condition of temperature as well as pressure. For example, the gas plus solid adsorbent, it will be forward reaction may be adsorption, backward reaction may be absorption. This is the absorption, this one is adsorption. So gas, G means gas, solid, S means solid adsorbent, gas molecule adsorbent and solid adsorbent, it will be converted to product, again it will gets the reverse condition under the same temperature and pressure. So this physis option, it can be get easily reversed. So that's why it is the reversible process. It is the reversible nature. Physis option is the reversible nature. But what about the chemisorption? That chemisorption, already surface compound is formed. So definitely, chemisorption, there is no possible for irreversible nature, because already surface compound is formed. Already due to the force of attraction between the gas molecule and solid adsorbent is very high, so there is no possible to get reversed. So chemisorption is irreversible in nature. But physis option is reversible nature. So that is the reversible nature of adsorbed layer of gas. The next one, enthalpy of activation. Next factor is enthalpy of activation. This enthalpy of activation, the activation generally is the exothermic in nature. The heat is evolved during the adsorption. Generally, enthalpy of activation is highly exothermic in nature. Heat is evolved during the adsorption. So especially the heat of adsorption is defined as the energy liberated when 1 gram mole of the gas is adsorbed on the solid adsorbent, and 1 gram mole of the gas is adsorbed on the solid adsorbent. That is the enthalpy of activation. So for physis option, what about the physis option? What about the chemisorption? So what is in the enthalpy of activation? The energy liberated when 1 gram mole of the gas is adsorbed on the solid adsorbent. So in physis option, for example, in physis option, the force of attraction between the gas molecule and solid adsorbent is very weak. So that's why the heat of adsorption is also very low. Near about 30 kilojoule per mole for physis option. Then what about the chemisorption? For chemisorption, just reverse, because the force of attraction between the molecule is very strong. So that's why the heat of adsorption is very high, near about 40 to 100 kilojoule per mole. So that is the enthalpy of activation. The next factors is maybe the nature and surface area of the adsorbent. So nature and surface area of the adsorbent plays the major role for determine the rate of adsorption. So if the molecules are maybe greater the surface area, greater is the adsorption, because when we increase, if the molecules possess the highest number of surface area, definitely it will increases the rate of adsorption. So first point. Next one, number two, the number of pores. The pores of diffused gases may be number of pores are maybe increases in the solid adsorbent, it will also leads to increases the surface area, so it will be directly proportional to the adsorption. So that is the second factor, nature and surface area of the adsorbent. So two factors, greater the surface area, greater is the adsorption. Number of forces are permits to diffuse the gases, like diffusion of gases maybe increases, automatically it will increases the surface area, it will leads to increases the adsorption. So that is the nature and surface area of the adsorbent. Next one, pressure of gas. Last one, pressure of the gas. So the pressure of gas, pressure, since the pressure of the gas also leads to decrease the adsorption, because physisorption directly proportional to pressure, but in chemisorption it will be inversely proportional to the adsorption, because the pressure as well as concentration. We already discussed difference between physisorption and chemisorption. When we increase the temperature, it will inversely proportional to the physisorption, but directly proportional to chemisorption. But one more factor, when we increase the pressure and concentration, it will be inversely proportional to the physisorption, but directly proportional to the physisorption, inversely proportional to the chemisorption. So same thing, when we increase the pressure, the physisorption may be directly proportional. For physisorption may be directly proportional, but when we increase the pressure, it will be inversely proportional to chemisorption. Inversely proportional to chemisorption. So that is the pressure of gas. So these are all maybe the factor affecting adsorptions of gas molecule and solid adsorbent. The following factors, like nature of gas, temperature of gas, activation of adsorbent, thickness of adsorbed layer of gas, reversible nature of adsorbed layer of gas, then enthalpy of adsorption, enthalpy of activation, nature and surface area of the adsorbent, last one, pressure of the gas. So these are all maybe the factors to affect the gas molecule and solid adsorbent. Next one, what about the factors affecting of solute from solution? Factor affecting of solute from solution. It's also having some factors. So first one, factor affecting of solute from solution. Factor affecting of adsorptions of solute from solution. This is the gas molecule and solid adsorbent. This one is solute from solution. Solute from solution. And finally, porous or finely divided particles will absorb the following two methods. Maybe the adsorptions of solute from solution, or it will give some preference to the certain substances. Preference to the adsorptions of solute from solution, it gives some preference to the certain substances. That is the two factors. And before that, the activated charcoal may be the best adsorbent. Activated charcoals may be adsorbed. Activated charcoal is the best adsorbent. It will absorb coloring matters present in the sugar solution. Coloring matters present in the sugar solution, or many dye stuffs present in the solution. Many dye stuffs present in the solutions. Then ammonia from mixture of ammonium hydroxide and phenolphthalein. Or one more example, like absorption KCl from KCl in water. So these are all maybe the example for adsorptions of solute from solution. Adsorptions of two factors. The factor affecting adsorption of solute from solution, it will be depends on the following two things. One is solute from solution, adsorptions of solute from solutions. The second one is adsorptions of certain substances from solution, or otherwise it will use the preference to the other substances. That is the two factors. First two factors may be solute from solution. Activated charcoal may be adsorbed, like the coloring matters present in the sugar solution, or dye stuffs may be present in the solution, or maybe ammonia from mixture of ammonium hydroxide and phenolphthalein, or KCl from KCl in water. KCl from KCl in water. One more example, like a mixture of acids. Mixture of acids like acetic acid and oxalic acid. Acetic acid and oxalic acid. Acetic acid and oxalic acid. In this case, the activated charcoal may be adsorb the acids, thereby acid concentration may be decreased. Acid concentration may be decreased. So these are all maybe the example for solute from solution. Solute from solution. So the solute from solution, especially the activated charcoal maybe is a best adsorbent. It will adsorb coloring matter present in the solution, dyestuffs in solution, ammonia from ammonium hydroxide and phenolphthalein, then KCl from KCl in water, then mixture of acids like acetic acid and oxalic acid, thereby the acid concentration may be decreased. So these are all maybe the best example for solute from solution. Next one, same adsorptions of solute from solution, certain substances. Solute from solution, factor affecting adsorption of solute from solution, like the certain substances, adsorptions of solute from solution, certain substances. Certain substances in preference to the other substances. Preference to other substances. That is the second factor. That is the second factor. So for example, here, if you use the alumina silica gel as well as alumina gel, or charcoal. First one may be the charcoal, best example. First one, charcoal is the best adsorbent. Charcoal, it will adsorb non-electrolyte more readily than the electrolyte material. So charcoal adsorb non-electrolyte more readily. Non-electrolyte more readily than the electrolyte material. Non-electrolyte more readily than the electrolyte materials. Then one more example, like alumina gel, Al2O3. Alumina gel, it will absorb, just reverse for the charcoal, because charcoal is adsorbed non-electrolyte more readily than electrolyte. Non-electrolyte more readily than the electrolyte materials, but alumina gel, it will absorb electrolyte more readily than the alumina gel, it absorb electrolyte more readily than the non-electrolyte. So this is the best example for adsorption of solute from solution, certain substances in preference to the other substances. So charcoals as well as alumina gels are best adsorbent, but charcoal, it will adsorb non-electrolytes more readily than the electrolyte solutions, followed by alumina gels, electrolytes adsorbed more readily than the non-electrolyte substances. So these are all maybe the two factors, adsorptions of affecting solute from solution, two criteria. Then what about the factors to affecting the adsorptions of solute from solution? Some of the factors are more or less same for gaseous molecule and solid adsorbent. Gaseous molecule and solid adsorbent. Some factors only we are going to discuss about. Some factors. We know very well what about the gas molecule and solid adsorbent, like nature of gas, temperature of gas, pressure of gas, activation of adsorbent, enthalpy of activation, nature and surface area of the adsorbent, thickness of adsorbed layer of gas, like that. Almost the same for the factor affecting of adsorptions of solute from solution. Few factors only we are going to discuss about. The first factor, when we increase the temperature, the magnitude of adsorption may be decreased. When we increase the temperature, magnitude of adsorption may be decreased. That is the first factor. So temperature also plays the major role. Then Second factors, the number of surface area may be high. Number of surface area should be high or increased. The magnitude of adsorption is also increased. Magnitude of adsorption is also more or increases. So first factor, temperature increases, magnitude of adsorption may be decreased, because we already discussed from difference between physisorption as well as chemisorption itself, because when we increase the temperature, physical adsorption is decreased. Same thing, that when we increase the temperature, magnitude of adsorption may be decreased, but number of surface area is one of the main factors to determine the surface area of the adsorbent. It will lead to increase the adsorption process. So the number of surface area may be increases, it will lead to increase the magnitude of adsorption. Second factors. Then third factors, the surface area of the solid is very high, adsorption is also very high. So the surface area of the mass of the solute is very high. Mass of the solute is very high. So the surface area of the adsorbent is magnitude of adsorption is also more. Magnitude of adsorption is also more or increases. So this is the three factors. Temperature increases, adsorption, rate of adsorption is also decreases. Number of surface area may be increases, the magnitude of adsorption is also increases. The molecular weight of the solid is also high, the adsorbent is also more. Then fourth factors may be the the adsorptions of solid from solution. We have to correlate with the Freundlich adsorption isotherm. Freundlich adsorption isotherm. Freundlich adsorption isotherm. Like this Freundlich adsorption isotherm is nothing but it's a simple mathematical form, x by m is equal to k into p whole power 1 by n. Whole power 1 by n. X by m is equal to k into p 1 by n. X is the mass of the x is the amount of gas adsorbed. X means amount of gas adsorbed. M is the mass of the adsorbent. M is the mass of the adsorbent. Mass of the adsorbent. K is the equilibrium constant. Equilibrium constant. Equilibrium constant. Equilibrium pressure. Sorry. P is the first one. P is the equilibrium pressure. K and N are constant. K and N are constant. This is the Freundlich adsorption isotherm. Freundlich adsorption isotherm. Freundlich is a scientist. He gives some mathematical forms about the adsorption isotherm, adsorption process. So x by m is equal to k into p power 1 by n. X is the amount of gas adsorbed. M is the mass of the adsorbent. K and N are constant. P is the equilibrium pressure. P is the equilibrium pressure. So this case, instead of pressure, you have to replace by the concentration. Instead of pressure, you have to replace by the concentration. So this will also obey the adsorptions of solute from solution. This may be the equation 1. This equation we are going to take the logarithm. So this instead of pressure, you have to put the concentration C. Equilibrium concentration. Equilibrium concentration C. Equilibrium concentration. It is a simple thing. We replace the pressure instead of concentration C. So these equations are going to take the logarithm. What about the logarithmic form? Taking log. Equation 1, taking log. Taking log. So log x by m is equal to log k plus 1 by n log c. Plus 1 by n log c. So this is the equation number 2. You see that almost it will be similar to straight line equation. Similar to straight line equation. Y equal to mx plus c. y equal to mx plus c, straight line equation. So we have to draw the graph between log of x by m versus log k. Sorry, log of x by m versus log c. The 1 by n may be the slope. Sorry, this one is slope. This is the intercept. Log k is the intercept. We should draw the graph between this experimental value according to the experimental value of charcoal adsorbed and acetic acid adsorbed and charcoal at 25 degrees Celsius. It will give the graph like that, like so. This is the log of x by m. This is the log c. So this is the example for acetic acid on charcoal. Acetic acid on charcoal at 25 degrees Celsius. At 25 degrees Celsius. So for example, this one is also explained by using one more method, like when we consider this, generally the adsorptions occurs two types. One is physical, positive adsorption, negative adsorption. Two types of adsorptions may be possible. For positive adsorption, first one will be the negative adsorption. Negative adsorption, first time, we have to consider in this case diluted KCl solution. Diluted KCl solution. In this case, if you add the charcoal, will be the best adsorbent. If you add the charcoal to the diluted HCl, here charcoal absorb water than that of the KCl. Because the water concentration is very high, if you add the charcoal absorb the water than that of the KCl solution. This for diluted KCl solution. So here it will give the negative adsorption. This will be the negative adsorption. Like log of x by m versus log c. So that is the negative adsorption. Then one more types may be the negative adsorption. One more things may be the positive adsorption. What about the positive adsorption? Positive adsorption. In this case, instead of diluted HCl, we have to consider concentrated KCl. Concentrated, not HCl, KCl. Concentrated KCl. In this case, if you add the charcoal, it will absorb KCl more than that of the water. So here charcoal absorb KCl, especially in concentrated KCl solution. If you add the charcoal into that concentrated KCl solution, charcoal absorb KCl more readily than that of the water. So it will produce the positive adsorption. For example, the graph may be like that. Log of x by m versus log c. So this is the positive adsorption. This one is the negative adsorption. Why it will be gets the negative adsorption? Here diluted KCl, here water is highest content than that of the KCl solution. If you add the charcoal, it will absorb the water molecule than that of the KCl solution. It will give the negative adsorption. But in this case, if we consider the concentrated KCl, it will give the positive adsorption. Why? Because the charcoal added to the concentrated KCl solution, charcoal absorb the KCl solution than that of the water. So that's why it will give the positive adsorption. Thereby concentrations of KCl may be decreased. Here concentrations of KCl may be increased. For diluted KCl, the charcoal absorb the water than that of the KCl means automatically concentrations of KCl may be increased. But here concentrations of KCl may be decreased. That's why it will give the positive adsorption. This one gives the negative adsorption. So that's why till now the precise mechanism of adsorptions of solute from solution is not clear. Precise mechanism of adsorptions of solute from solution as well as gas molecule and solid adsorbent is not clear. So, adsorptions of gas molecule and solid adsorbent is not clear. Gas molecule and solid adsorbent as well as solute from solution. Both the things, the precise mechanism of adsorption reactions is not clear. However, it has certain limits. So, next one, what about the applications of adsorption? The applications of adsorption using most of the methods most of the techniques. So far, applications of adsorption, general application. Applications of adsorption. First one, productions of high vacuum. Productions of high vacuum. Most of the silica gel, alumina gel, fuller's earth or charcoal materials mainly used for the productions of high vacuum. First point, productions of high vacuum. Productions of high vacuum. This is the first application. Next one, gas mask. Productions of it will be act as the gas mask. The adsorption process mainly, especially the Al2O3 here, Al2O3 or SiO2 or charcoal like that. Same the gas mask. Here also the same Al2O3 material or SiO2 materials used as a gas mask. It will capture the most of the impurities present in that mixture. So that is the second application. Third one, it will be the adsorption process mainly used in chromatographic analysis. Chromatographic analysis. Chromatographic analysis. The chromatographic analysis, it will also the chromatographic analysis. This techniques used to separate small quantity of organic mixtures or coloring matters present in that mixture. That use the SiO2 or Al2O3, etc. These types of materials used to capture the coloring matters or small quantity of organic mixture, organic compounds present in the mixture. You have to segregate by using the adsorption method. That is the third method, chromatographic analysis. Fourth one, froth flotation method. Ore dressing froth flotation method. Ore dressing froth flotation methods. In presence of like a lot of sulfur compounds like lead sulfide, copper sulfide, zinc sulfide, the sulfur compounds are easily segregated by using oil. This will absorb sulfur components present in that mixture easily. That is the ore dressing froth flotation methods. This is also one of the best application for adsorption. Then fifth one, humidity control. Humidity control. These humidities are easily controlled by adding the alumina Al2O3, alumina or silica SiO2 or calcium chloride. This substance are mainly used to control the excess amount of humidity present in the room. So that is the humidity control. It will also involve same adsorption process. Then sixth one, softening process, water softening process. Water softening process. We know very well, generally the water contain hardness producing salts like calcium and magnesium salts. We have to use the suitable ion exchange resin or zeolite materials. If you pass the water into that materials, what will happen? Both calcium and magnesium salts are easily absorbed by the surface of the material resins. Then we get the soft water. So that is the softening process. Especially calcium and magnesium may be present in the hard water. You have to remove by using resins. It will absorb on the surface of the material. Then we get the soft water. So that is the softening process. Then next one, to minimize the evaporations of water by using the stearic acid. Stearic evaporation, minimize the evaporation. Minimize the evaporation by using stearic acid. By using stearic acid, it will be spread out on the lakes or other reservoir. It will reduce the evaporations of water. it reduces the evaporations of water. So it will be also one of the applications of adsorption. The next one, lubrication. So lubrication, here the graphite materials may be act as the best lubricant. Graphite materials may be used as a best lubricants. If you add the graphite material inside the engine part, it will absorb the excess amount of impurities present in the engine part. So that is the lubrications. The next one, softening out process, then humidity controls, overdressing, chromatographic analysis, gas mask, productions of high vacuum, like that. They minimize the evaporations of water, then lubrication process. So these are all maybe the applications of adsorption process. So in this class, we discussed from what about the factors affecting adsorption, and before that, what about the surface tension, adsorption, absorption, adsorbent, adsorbate, followed by sorption. Then next one, we discussed like what is the difference between adsorption and absorption. So adsorption is a surface phenomenon, absorption is a bulk phenomenon. So what is the difference? Like the concentrations of the molecule should be adsorbed more on the surface of the things than that of the bulk. So that is the, then it will records equilibrium attains very easily. This will take more. Then it is highly specific in nature, it is not specific in nature. So these are all maybe the simple difference between the adsorption and absorption. Then what about the classification of adsorption, like physisorption and chemisorption? So physisorption is the physical adsorption, or another name may be the weak van der Waals adsorption. Then chemical adsorption is another name, chemisorption or activated adsorption. So this physisorption due to the weak van der Waals forces between the two molecules, but chemisorption, it is the strong chemical bond formation between the gas molecule and solid adsorbent. So what is the difference? Simple difference, like this is the weak van der Waals forces, this is a strong chemical bond formation. It is a reversible nature, it is the irreversible nature. Then it is, when we increase the temperature, it will decrease the physical adsorption, but chemical adsorption may be direct proportional. It will increase the rate of adsorption. When we increase the temperature, it will increases the rate of adsorption. But the temperature, pressure and concentration, physical adsorption may be directly proportional, but chemical adsorption may be inversely proportional. Then what about the heat of adsorption is very, very low for physisorption, but chemisorption heat of adsorption is very high, from 40 to 100 kilojoules per mole. Then equilibrium attains very easily for physisorption, but equilibrium times take more time. It is highly specific in nature, there is no possible such effect. So these are all simple difference between physisorption and chemisorption. Then what about the factors affecting adsorptions of gas molecule and solid adsorbent? And before that, what about the characteristics of general adsorption? The characteristics of general adsorption is a selective process, it is a spontaneous process, it takes place no time, it is accompanied by the physical followed by chemical adsorption. Then it is a decrease in the free energy as well as entropy. This adsorption mainly depends on the temperature dependent. So it will also mainly depends on the nature and surface area of the adsorbent. So these are all general characteristics of adsorption. Then what about the factors we already discussed in the factors, I mean gas molecule and solid adsorbent, like nature of gas, temperature of gas. Nature of gas, the nature of gas, it should be like weak van der Waals forces. Those species are having highest weak van der Waals forces, it will be rate of adsorption should be very high. And then one more thing, if the gaseous molecules having highest critical temperature, the adsorption is also very high. Then what about the temperature of gas? You increase the temperature, physical adsorption may be decreased, chemical adsorption may be increased. Then what about the pressure of the gas? Physical adsorption may be increases directly proportional, chemical adsorption may be the inversely proportional. Then fourth one is the activation of adsorbent. The activations are achieved by the following two methods, like rubbing mechanically, then followed by increase in the surface area of the adsorbent. Then fourth one, what about the thickness of adsorbed layer of gas? In physisorption, it will be form only monomolecular thick layers. Then chemical adsorption, physical adsorption, it will be form multimolecular thick layer is formed. Chemical adsorption form monolayer. Then what about the reversible and irreversible nature of adsorbed layer of gas? For a physisorption, it is the reversible nature, but in chemisorption irreversible nature because surface compound is formed. Then, but physorption, why it is the physorption is reversible nature? Because weak van der Waals forces exist between the gas molecule and solid adsorbent. Then what about the enthalpy of activation? Like activation leads to increase the adsorption, like this enthalpy of activation, especially the adsorption is exothermic nature. Heat of adsorption is defined as like energy liberated when 1 gram mole of the gas adsorbed on the solid adsorbent. But in physisorption, the heat of adsorption is very low because due to the weak van der Waals forces between the gas molecule and solid adsorbent. But chemisorption, the force of attraction between the gas molecule and solid adsorbent is very high, so that's why the heat of adsorption is very high. For example, from 40 to 100 kilojoule per mole. Then nature and surface area of the adsorbent. So the surface area of the adsorbent should be greater the surface area, greater is the adsorption. Then one more thing, maybe the diffusion of gases maybe permits to increase the surface area, it leads to increases the adsorption. So these are all maybe the factor affecting gas molecule and solid adsorbent. Then one more thing, factor affecting solute from solution. So here two important factors to determine the solute from solution, like adsorptions of solute from solution. Here maybe activated charcoal maybe the act as the best adsorbent. It will absorb the coloring matter present in the solution, then disrupts present in the solution, then mixture of acids, thereby concentrations of acid may be decreased. Then ammonia from mixture of ammonia reduction and phenolphthalein, then KCl from KCl and water. So that is the adsorption of solute from solution. Then adsorption of solute from solution is preference to these certain substances and preference to the other substances. Like here maybe the two things, charcoal and alumina may be used it. So charcoal used in mixture of electrolyte as well as non-electrolyte things. Here charcoal absorbed non-electrolyte more readily than the electrolyte solution. But alumina, it will absorb electrolyte more readily than the non-electrolyte solution. So here also some factors almost laid down the what we discussed in the gas molecule and solid adsorbent. Some of the factors also we are going to listed here. So what is the factors? When we increase the temperature, the magnitude of adsorption is also increases. Then when we increase the surface area of the adsorbent, it will be directly proportional to the magnitude of adsorption. Then third one, when we increase the molecular rate of the, if the molecular rate of the solid is very high, adsorption is also very high. Then one more factors like Freundlich adsorption isotherm, we are going to use the adsorption of solid from solution, like Freundlich adsorption isotherm mathematical form, like x by m is equal to kc into whole power 1 by n. Here instead of concentration, kp into 1 by n. Instead of pressure, we have to use the concentration. So x is the amount of gas adsorbed, m is the mass of the adsorbent, k is the equilibrium concentration, c is the equilibrium concentration, k and n are maybe the constant. So in this equation, we are going to take the logarithm, like log of x by m is equal to log k plus 1 by n log c. So we should draw the graph, we will give the straight line, especially the charcoal adsorbed and acetic acid adsorbed on charcoal at 25 degrees Celsius. So log of x by m may be the y-axis, log c may be the x-axis, got the straight line. So in this trend, we are going to explain by using the two different types of solutions, like concentrated HCl as well as diluted HCl. For example, diluted HCl, we have to use the charcoal. The charcoal adsorbed KCl solution, charcoal absorbed the water than that of the KCl solution. For this one is maybe the diluted HCl. This way it will leads to gives only the negative adsorption. For same thing, we have to use the concentrated KCl. Charcoal adsorbed concentrated KCl more than that of the water. So thereby here positive adsorptions may be take place. So that's why the precise mechanism of adsorptions of solute from solution as well as gas molecule and solid adsorbent is not clear. So till now the research will be going on. So what about the general applications of adsorption? So applications of adsorption may be productions of high vacuum, then gas mask, kettle bags of the gas mask, then chromatographic analysis, overdressing, flotation methods, humidity control, softening of water, then minimize the evaporation of water, then lubrication process, like that. Okay, thank you.